international companies such as DHL and UPS. It was founded in 1982, and it's located at the crossroads between the East and the West in UAE. Thus, it's known for its customized logistics solutions anywhere in the world. Moreover, companies have three bottom lines: economic, social, and environmental. And according to Aramex third bottom line, it's the first company in the region to release an audited sustainability report that showcases its commitment to its key stakeholders, the community, and the environment. And last year, they celebrated their 10th report. Moreover, Aramex started off as an express mail delivery, but with time they expanded their operation to other aspects of logistics, where now Aramex is covering all the aspects of its client supply chain from the moment the vendor leaves their suppliers to the moment they reach their retailers. So Aramex is acting as a third-party logistics provider to their clients to provide them with transportation and warehousing services. However, 3PL companies such as Aramex, DHL, and FedEx face some challenges, and some of these challenges are cutting transportation costs, lacking control and visibility, and improving customer service. These challenges led us to our problem statement with Aramex, where Aramex now is looking for a way to improve the efficiency of their resource utilization while maintaining their delivery responsiveness. So, companies such as Aramex that rely on transportation and their service need to adapt to certain solutions and functions such as fleet management systems and optimizing vehicle routing. So, on one hand, fleet management helps companies to minimize the risks associated with their vehicle routing, improve efficiency and productivity, and reducing their overall transportation and staff costs. These functions can be provided by either an in-house department or an outsourced provider. On the other hand, Aramex culture is set up on delivering their promises to their customers, and Aramex customers expect their orders to be correct and delivered on time, despite last-minute changes, equipment failure, or heavy traffic. Thus, Aramex is always looking for transportation routing and logistics solutions such as vehicle routing that optimizes the daily operation by dynamically scheduling their deliveries, loads, and orders. And by this, Aramex will eventually increase their financial and customer value. As a result, our objective of this project is to manage Aramex fleet and to optimize their vehicle routing. And our focus will be only on the big 3PL clients, such as Dubai Duty Free, Midas, Do, and Vice Versa. Moreover, our design objective is to improve fleet visibility, minimize the distance traveled by their trucks, minimize the running costs such as fuel, maintenance, and insurance, achieve sustainability by reducing the carbon emissions, and finally, maximize the workload utilization for each truck. And now I'll leave the floor to my colleague Mahmoud to talk about the literature review and methodology.
Thank you, Zara. Starting with the literature review, we start by defining fleet management system. A fleet management system composed of certain components that work together to provide the company with different functionalities for monitoring their fleet. The most basic function of a fleet management system is providing location data. Here's a figure of how simple fleet management should look like. Moving on to technologies used in fleet management. The first technology is the Internet of Things. Then we have radio frequency identification tags. Then onboard diagnostics, and finally, global positioning systems. These technologies combined could be used to create something known as the automated vehicle location. The automated vehicle location utilizes GPS in order to be able to locate the truck at any point in time. And moreover, a chip is inserted into the onboard diagnostic boards, which allows the company to monitor different parameters such as the speed of the vehicle, for example. Moving on to our second topic of interest is the vehicle routing problem. The vehicle routing problem is defined as the design of a set of vehicle routes with minimum cost and time criteria, starting and ending at the same depot, and for a fleet that services a set of customers. Some variations of the vehicle routing problem are as follows. We have the vehicle routing problem with time windows, the vehicle routing with multiple trips, and finally the capacitated vehicle routing problem. Moving on to the methodology, we start by the issues phase. As mentioned by Sarah, the issues that Aramex face is optimizing their vehicle routing as well as increasing their visibility within fleet. What we did in Senior 1 is we tried to analyze the current system and understand the system to be able to define the flaws and come up with real-world applications of how we can improve the system. The current scenario at Aramex is that they rely on the dispatcher for them to schedule assignments to the different drivers. Moreover, the driver is responsible for choosing how he's going to allocate the shipments inside the trucks. In addition, Aramex is not able to locate all the vehicle at all times or the shipments. And finally, the driver chooses the route he is going to take based on his expertise and knowledge in traffic and road conditions given the time of delivery. Possible solutions, we start with the fleet management. We are planning to implement a combination of different systems that will be utilized to allow Aramex with better fleet management. First off, we're going to be using a GPS tracking system. The GPS tracking system will give them the ability to locate the truck at any point of time. Moreover, we'll also be using sensors such as CO2 emission sensors, fuel consumption sensors, as well as braking and acceleration rate sensors. Finally, we're going to use a barcode scanning system that will scan the shipments at time of loading and unloading, and it will synchronize with the GPS tracking system so that the company will be able to tell where the shipment was delivered and at what time it was delivered. Moving on to our second problem, the routing mechanism. We are planning to study the previous models and be able to modify them so that we can create a model that's compatible with our problem. The model will enable us to have a more systematic way of assigning the routes to different vehicles. And my colleague Bora will continue with the objective and significance.
Thank you, Mahmoud. Regarding the objectives and significance, our project will result in more efficient and productive operations leading to better customer satisfaction by assuring that the right quantities are in the right shipments in a good quality and delivered to the right customers within the right time window and at the minimum cost. Moreover, to allow managers to obtain the necessary information on fleet-based projects, as managers will be able to view that how many trucks are leaving the facility per day and the capacity of each truck and is the utilization of each truck, was it utilized in the right way or not. Furthermore, less fuel cost by optimizing the routes each driver has to take to deliver the shipments. And by minimizing the routes traveled, we will be minimizing the cost, the fuel cost, and hence we will be minimizing the overall cost. Moreover, to reduce the CO2 emissions, as organizations now currently trying to reduce the CO2 emissions coming from the truck's exhaust for the global warming, so we can live in a more green plant and to reduce the damages to our plant as well. Moreover, to improve the driver's driving attitude, as Aramex supervisors will be receiving every day reports for the speed of each truck, the acceleration for each truck, the CO2 emissions coming from each truck's exhaust, and the fuel consumption for each truck. As well as they'll be controlling also and monitoring the driver's attitude, as they'll be able to know that each driver where is the location of each driver and is he working right now or slacking off. Moreover, less corrective maintenance needed for the truck, as we all know that corrective maintenance costs a lot more than the preventive maintenance. So by that, there will be more preventive maintenance and less corrective maintenance. To improve the road planning for each driver by the proposed routing optimization application, and by that, each driver will be able to view like which routes have more flexibility and which routes have a traffic jam to avoid. For example, let's say like a driver can view that like on Sheikh Mohammed bin Zayed Road, there is a huge accident and it's causing a lot of delays, so that driver needs to know that I need to avoid that route and to move on to another route. The alternative routes will be proposed by the routing optimization application. Finally, better customer satisfaction, since customers can also track their shipments and they can have real data about their shipments, so that the Aramex will be strengthening the operations with their clients, and hence the revenue overall of Aramex will increase. And now regarding the preliminary analysis, my colleague Mohammed will explain that.
Thank you, Bora. Good afternoon, everyone. So moving on to the preliminary analysis. Initially, the company provided us with the data for the last month and of the current year. We collected around 2,400 deliveries. Here's a sample of the provided data. Each order contains entries such as the client's name, driver's name, quantity per order, delivery date, and the delivery status, either it's scheduled, rescheduled, or undelivered. So after analyzing the data provided us with some insights about how the operations are going. For example, the first observation is each driver is always assigned to a specific area. For example, as we can see here, driver Ahmed is always assigned to all the companies located in Jabda, Dubai. As mentioned from Aramex team, that the same driver is always assigned to the same place because of his experience in the location routes. Second observation is some shipments fail to be delivered because some clients prefer the time that they will be receiving the shipment. as mentioned here, that this company, they can receive the shipments only from 8 a.m. till 5 p.m. on weekdays only. And the shipment, it was out of delivery on Saturday, so it did not reach the company, so the service was undelivered. So in order to improve this data, we can take the allowed delivery time into consideration and record the starting and finishing time of each shipment. So we came up with some assumptions and design constraints based on our meetings with Aramex and based on our analysis of the data. The first assumption is the number of trucks and customers is our constant. As we agreed with Aramex team that we need to optimize what's available and we cannot suggest adding more trucks. The second assumption is calculating the future demand for a specific client is based on the historical data of this specific client. For example, if Budget Hotel had 50,000 deliveries per month on average, they will predict for the next month they will also have around 50,000 deliveries. The third assumption is drivers will work only maximum 12 hours per day, and the last assumption is one driver is equal to one truck, no assistant drivers. Moving on to the design constraints. So the first constraint is, as we will propose a vehicle routing application, the first thing that we should take into consideration that we need to design it should have a simple interface in order to suit the level of education of the drivers with the minimum number of trainings. The second constraint is that, as we talked before, that some clients define the time that will be receiving the shipment, which will put a limit on when the delivery can be made. And the last one is that Aramex have a limited number of trucks dedicated for third-party logistics. For example, they have 10 dedicated trucks only for Midas company, and of course, each truck have a limited capacity. Moving on to the conclusion, throughout Senior Design 1, our team profound a good understanding about the processes happened in Aramex. We identified new technologies along with their application throughout our literature review that will help us in the fleet management and vehicle routing. We also have a clear objective of what we should do in Senior Design 2, and our proposed model in Senior Design 2 will help the company improve its operations, increase the customer satisfaction, and utilize its resources. So before ending, I'd like to thank the Industrial Engineering Department for creating for us such a great opportunity to deal with the external market. I'd like to thank Aramex team for their support, and a special thank for Dr. Zaid Mahroun and Dr. Abdurrahim Shamaili for their continuous hours throughout the semester. You couldn't make it without your instructions, and thank you all for attending. Feel free to ask any questions.
Okay, any questions from the audience, please?
Perfect presentation.